In this second video on decorators, we're going to explain exactly what a decorator looks like using regular Python syntax. Here's the same example we had in the prior part. That is, a function that's defined within another function and a function that we're going to decorate. And as you can see, and as we described in the last video, this function, which is called this function, has been replaced by wrapper. This function is wrapper. And wrapper calls this function. Remember, my func is this function. I know this kind of thing makes your eyes cross, but if this is of limited understanding right at the moment, it might behoove you to go over this as many times as necessary until it starts to make sense. It all has to do with references to functions, and these references to functions have been passed to other functions and from another function. So this function now, when we call it, we're actually calling the imposter. We're calling the wrapper function because the wrapper function was returned from my decorator, and the wrapper function which calls the original function as well as does a little bit more, because as I mentioned, decorators augment any function. Now, the way we turn this into a proper Python decorator is by replacing this assignment with something we call Py syntax. That is, we say we actually replace this entire thing. And we replace it with something called Py syntax, where we say my decorator. Now, what you see with this my decorator is what you see on line 19. That is, calling my decorator and replacing the original function with a new function. In other words, reassigning the name to a different function. That's what this Py syntax does. The Py syntax says, let this function be replaced by the function that comes back from my decorator. Let this function be replaced with the func from my decorator. That's what Py syntax says. It says, let this function be replaced with the function returned from my decorator. Now, of course, the function that's returned from my decorator can do anything. It doesn't need to call the original function. But the whole idea of a decorator is to augment what a function does. It's an easy way to say, yeah, do what this function does, but I want you to do a little bit more. Do these other things as well. This is the idea of a decorator. It's a bit of a convenience, but it's actually a pretty profound convenience. It means that we can define functions in modules and other places that can be added to any function we wish. It's almost like saying, add salt to this dish. Whatever the dish is, let's add some salt. We would use this, perhaps, to maybe log what's happening. At this time, we are calling, this func. And here we might say, and whatever, this time could be the current time. At this time, we are returning from this func. You see the idea, when I say my func, just to make it clear, it wouldn't be this, but the idea is that we might, let's say, log the start and end times of a function. Or as I mentioned, we might convert a value that comes back from the function into a different currency or do some other processing. The best example I can think of is logging. You perhaps want to log the execution time of a function by saying, okay, first we're about to call this function, or we're just calling this function, and this is the time. And then when it's done, mark the time again. And then you can know how long it took to run that function. And that might give you some insight as to what's efficient or inefficient in your program. In order to make this complete, though, we're going to need to deal with function arguments. And this is the thing. Our decorator here works just fine, but it sort of assumes that the function is going to be called without arguments, right? We see that this function doesn't take any arguments. We see that wrapper doesn't take any arguments, and it's calling my func without any arguments. And all of that works perfectly, no arguments at all. But what would happen if we decorated a function with another function and we didn't call it properly in here? Let's say that this function takes an argument. And when we call this function, we're expected to call it with, hey. Well, we would have a problem right away, because if this function is actually calling wrapper, then wrapper would need to expect an argument, right? We know that if the function doesn't expect an argument and we try to pass it one, we're going to have a problem. So we'd have to put an argument here, and we'd have to put an argument here. But here's the thing, and I mean this could work as well, but here's the problem. Or I'll say iarg. Here's the problem. When we create a decorator, we want to be able to decorate any function, not just a function that takes one argument. We want to be able to decorate any function so that we can augment that function. So we would like to create a kind of an all-purpose sort of decorator that can accept any number of arguments. And how could we possibly do that when positional arguments are required and they need to be written in there? In other words, what if we had a second function and that function doesn't do anything? What happens if we try to decorate this function and have it also take advantage of that augmented function, that functionality? Well, this would be a big problem, because if we called do, it would be calling wrapper, and wrapper expects one argument, and so we would get a problem. It wouldn't allow us to call do without an argument. So how do we possibly handle this? Well, we're going to handle it through something called args and kwargs. Take a look at this function, print args, which expects two positional and allows for two keyword arguments. This is a function like any other. But as we've said, if this function is going to work properly, it's going to require that the user pass two arguments, because it's expecting two positionals. And it's also going to expect that if we pass two keyword arguments, that those keyword arguments would need to be defined up here. What we're really looking for is some built-in way to make this work. We are going to replace the arguments up here, which I guess we'll put in a comment so we can see what they were. We're going to replace these with two special new variables, args and kwargs. Now, we're no longer going to print w, x, y, and z because those have not been defined yet. Instead, we're going to print args, and then we're going to print kwargs so that you can see what they are. Let's take a look. Okay, this is very interesting, and if you'd like to pause right now to try to discover it for yourself, I would do that. Args is a tuple. It's a tuple with 5 and 10. And kwargs is a dictionary. It's a dictionary with y is 100 and z is hello. Why? Well, args and kwargs are very special entities. They're special new entities. Args with a star in front of it, and it doesn't need to be named args, but you should name it args. Args is going to collect all positional arguments. Args is going to collect all positional arguments. And kwargs is going to collect all keyword arguments. These entities are specifically designed to expect multiple values in the case of args and collect them into a tuple. Doesn't matter how many there are, it's going to make a tuple out of them. And kwargs with the double star, and again, it doesn't have to be called kwargs, but that's our customary approach. Kwargs is going to expect multiple keyword arguments and it will collect them all no matter what they are. This makes for a function that's extremely flexible. You can call it with any number of positional or keyword arguments. I could, make a new argument called ZZ, and if I do that, it will give me a dictionary with ZZZ as a key. Same thing is true with the positional arguments. I could omit them entirely, in which case I would just get back an empty tuple. So args and kwargs are like accordion variables. They'll just expand or contract based on what you send to them. And this is the beginning of our being able to create a decorator that can expect any number of arguments. In fact, why don't we go back? Maybe we're doing it here. Let's start with this decorator. And let's say that we'd like to decorate, any number of functions that have any sort of signature. Let's pass, instead of expecting A, B, X, and Y, let's ask for args and kwargs. Now, if we have a different function, maybe that doesn't take any arguments, or it just takes one positional argument or something like that. Our old favorite doublet. And we're going to pass it 55, and we're expecting back, it's going to return the value that was passed doubled. If we were to decorate this, and again, don't forget, this means that doublet will be replaced with wrapper. We can know that we can call this function, which is wrapper, with two positionals and two keywords, or we can call wrapper with just one positional. Or no positionals, or no keywords, and multiple keywords. It doesn't really matter. Args and kwargs are going to collect them. But here's where it finally gets put together. If we're going to call the original function, and remember, this is the original function, whether it's doublet or this function, my func is the original function, right? Because the decorator sent the function up and it got assigned to my func. If we're going to be able to call either doublet or this function through my func, we're also going to need to be as flexible. And what we can do is pass args and kwargs, this time as arguments. Now this is obviously getting a little involved. We've established that args and kwargs are a tuple and a dictionary. But if we take that tuple and that dictionary and pass it to a function, use them as values with the star and the double star, they will go back to being spaced arguments, positional arguments, or keyword arguments. And that's a little bit difficult to explain. It basically indicates that my func is going to receive the positional and keyword arguments that were originally passed to wrapper. Those will be passed on to my func. And then the last thing we're going to need to do, because doublet, let's call doublet with 5, and we should get back 10, is that if we're going to return a value from doublet, which should be 10, we're going to need to return that value from wrapper. Now we have a return statement here, but this isn't returning from wrapper. This is returning from my decoration. This is the original decoration of the function. Instead, we're going to need to say that val equals, or vals equal, and we're going to return vals. This will allow us to decorate multiple functions with multiple configurations of arguments and return values. This function doesn't expect a return value. We're going to call it without one. Double it expects one return value, so we're going to call it expecting one back. But remember, when we're calling this function and we're calling double it, we're not calling those functions. We're calling wrapper. Let's run this and see if it works. Okay, so I'm getting first the call to this function. And that is, it's printing something's happening. It's calling this function with the arguments. And then that's it. But if we decorate double it and we call double it, we see that, oh, yeah, nothing was printed. But if I go ahead and print val, I'll see that val is 10. And it did what it was supposed to do. It did something on its own. It called the original function with whatever arguments were passed to it, or passed to the wrapper, and it returned whatever was returned. So it's successfully returning 10 from wrapper, as if it were being returned from double it. Okay, this is a lot, and as I said, this is the most complex thing that we do in this class. I recommend, if you're really dedicated to learning this and doing the extra credit, I recommend that you look over these videos as often as you need, as many times as you need, to try to understand what's going on and send me questions as they come up. Best of luck. I'm with you all the way.